In today's video, we're going to talk about acids. So far, we've discussed how to write the names and chemical formulas of ionic compounds, and that includes the ones that have Roman numerals, that includes polyatomic ions, and we've also discussed covalent compounds that use prefixes mono, di, tri, etc. So the last type of naming that we need to be familiar with are what are called acids. So some common acids that you may have already be familiar with in real life, maybe hydrochloric acid, maybe sulfuric acid, carbonic acid, etc. Okay, technically acids are covalent compounds because they are made generally of all nonmetals. However, when given the name or the formula of an acid, the process of writing the name is a little bit different. You don't use those prefixes basically. So first of all, how do you know if something is an acid rather than just a regular covalent compound? Okay, one of the easy ways is if I give you the name of an acid, of course, the name of the acid will end in acid. Okay, every acid, if I give you the name, will say nitric acid, hydrofluoric acid. It always has the word acid at the end. So obviously that's one way that when you're given the name, you know that it's an acid. Now, what about the other way? What if you're given a chemical formula? How can you identify it as an acid? Okay, and the easy way, the way we're going to do for now, is if it begins with a hydrogen atom, and let me put in parentheses here, other than water. Okay, if it begins with a hydrogen atom, you treat it as an acid. So HCl, oh, you see a hydrogen in the front, acid. HC2H3O2, acid. H2SO4, acid. H3PO4, acid. Anytime it starts with a hydrogen, unless it's water, you treat it as an acid. Now, just like with ionic compounds, remember with ionic compounds, we dealt with binary ionic compounds and what we call ternary ionic compounds. Okay, acids are kind of similar to that as well, in that there's two different types of acids. They're what we call binary acids and what are called oxyacids. Okay, and a binary acid is an acid that only contains hydrogen and one other element and doesn't contain oxygen in it. Okay, again, that kind of helps you understand that's not an acid. Okay, so some examples of binary acids might be HCl, HBr, H2S, H3N. Okay, all of those are different binary acids. Notice they only contain hydrogen, and it doesn't matter if there's more than one hydrogen, they still just contain hydrogen and then one other element. Okay, and that other element cannot be oxygen. Okay, in an oxyacid, those are acids that, again, typically contain hydrogen and then two or more elements, one of which must be an oxygen. Okay, let me give you a couple examples of those. H2SO4 is an oxyacid. H2CO3 is an oxyacid. HNO3 is an oxyacid. H3PO4. Those are all different examples of oxyacids. Okay, next question. Who cares? Why does it matter if it's binary or oxy? Okay, so let's start, first of all, we're going to start with our binary acids. So we're going to start with writing the formulas of these acids. So writing the formula of an acid is pretty straightforward, whether it's binary or oxy. The only trick to writing the formula of an acid is to determine how many hydrogen atoms go in front of the acid. Notice here I put one hydrogen. Here I put 3, here I put 2, here I put 2. Even up here in the binary, there's one hydrogen, two hydrogens, and then 3 hydrogens. Okay, to know how many hydrogens go in the front, you look at the charge of that negative part of the acid. Okay, you look at the PO4, you look at the NO3, you look at the CO3, you look at the N, you look at the S, and you go, what charge does that have? For example, PO4 is phosphate, and that's PO4 3 minus, and that's earlier in the notes when we talked about polyatomic ions. So since it has a -3 charge, we need 3 hydrogens to cancel that out. Okay, for these two, sulfate is SO4 2 minus, and carbonate is CO3 2 minus. Okay, that's a 2 there, sorry. Okay, So since they both have a -2 charge, notice that we need 2 hydrogens to cancel out the -2. So, and here's an example. Acetic acid contains acetate. Okay, and we'll get to how we know that here in just a second. And acetate has a formula of C2H3O2 with a charge of -1. And since acetate has a charge of -1, we need 1 hydrogen. Because remember, hydrogen is H+. It has a charge of +1. So kind of like ionic compounds, we have to cancel those charges out. Okay, in another example, hydrosulfuric acid contains sulfur. Sulfur, just by looking at the periodic table, sulfur has a charge of -2. We know that looking at what we've learned when we talked about ionic compounds. Sulfur has a charge of -2, so we need 2 hydrogen atoms to cancel that out. So the formula is H2S. So anytime you're asked to write the formula, that's the goal, is how many hydrogens do I need to cancel out those negative charges? All right, so, and we'll get to that part here in just a little bit, okay? So when you're writing the name of an acid, it's really, really important whether it's binary or oxy, okay? And the reason is because let's look at 2 different acids here. Let's look at HCl and HClO3. Well, Cl is chlorine, so you would think the name of that would be hydrochloric acid. Okay, but then this one is chlorate, and you might think, oh, that's hydrochloric acid. Notice how you have 2 different chemical formulas, but if you just kind of like, well, it's got a hydrogen in the front, and then it's got chlorine and oxygen, or just chlorine, so it's hydrochloric. You can't have 2 different acids with the same name. Okay, and HCl and HClO3 are 2 very different acids. So the key is, if it's a binary acid, and you can see it right here versus here. If it's a binary acid, you put hydro in the front. So this is hydrochloric acid. If it's an oxy acid, this is an oxy acid. It's got oxygen in it, right? If it's an oxy acid, then you do not put hydro in the front of it. You just take the name of this, which is chlorate. Again, look at your previous in ionic compounds when we learned that that's the ClO3 is chlorate, and that just becomes chloric acid. Notice the difference. The binary acid has hydro in the front of it. The oxy acid does not, and that's the key right there. Okay. So notice the only difference between the 2 is that a binary acid has hydro in front of it and an oxy acid doesn't. Why does a binary acid have a hydro in front of it and an oxy acid doesn't? Is because, again, we've got HClO3, that becomes chlorate, so that's chloric acid, and then we would have the same names, and we don't want to have that. So let's go ahead and do these first examples, these first 6 examples here together. So letter A says HBr. So right away, that's a binary acid. So I have to put hydro in the front of it. Br is bromine, so it becomes bromic. And then we put acid at the end. Hydrobromic acid. Okay, look at letter B. We see that oxygen there. That means we don't put hydro in the front of it. Okay, and SO4 is sulfate. And sulfate, sometimes students put sulfic. I'm not going to mark you wrong if you do that, but the actual name is sulfuric acid. Again, don't worry about the exact spelling of it. Okay, but you can't put hydro in the front of it. Okay, HClO3 has, again, oxygen, so no hydro in the front of it. It's an oxy acid. And chlorate becomes chloric acid. Okay, letter D, you've got the hydrogen in the front, then you've got hydroxide. So that would be oh, nope, I'm just messing with you there. It looks a little bit weird, but HOH is just another way of writing H2O. And that's really just water. Just put that in there to kind of mess with you a little bit. Okay, H3N, again, no oxygen. As soon as you don't see an oxygen, write that hydro down. And then N is nitrogen, so that becomes nitric. So hydronitric acid. And then our final one, HF, again, no oxygen, so it's hydrofluoric acid. All right, let's practice this and canvas a little bit.